So the Pythagorean identity obviously has to do with Pythagoras. And so we're going to have a look back at our first quadrant and the triangle that sits here that we pulled out to the side before. Now we did some Year 9 trigonometry for theta here, and we found that cos of theta was a over 1, which is just a, which gives us cos of theta is a, and sine of theta is b over 1, which becomes just b. So if we take Pythagoras' theorem here, c squared equals a squared plus b squared, our c squared is our hypotenuse, and so our hypotenuse on this triangle is 1, and a is cos theta, so it's cos theta squared, and b is sine theta, so it's sine theta squared. This gives us our Pythagorean identity, which is this thing here. Now the 1 is normal. You'll see here that there's a little squared after the word cos. This is a convention that's used to, in a shortcut, represent cos of theta squared. It's meant to help with the difficulty of discerning between cos of theta all squared or cos of theta squared. So the difference between the two. So even though it's written at cos squared theta, it actually means cos theta all squared. And the same with sine squared theta actually means sine theta all squared. So how do you use this? So the Pythagorean identity can also be written, if you swap the left-hand side and the right-hand side of the equations, as cos squared theta plus sine squared theta equals 1. And so what you've got here is a relationship between cos of an angle and sine of an angle. And so if you're given one of those values, if you're given sine of theta, you can find cos of theta. Or if you're given cos of theta, you can find sine of theta. And that's what we're going to do now. So we have given that cos of theta is 3/5 and 3.2 is less than theta is less than 2 pi, which means that this angle here is in the fourth quadrant. We need to find sine of theta. So we're given cos, we need to find sine, so we're going to use our Pythagorean identity to help us. So let's start with that. So there's our Pythagorean identity there. If it helps to write it in its squared form, then go right ahead and write it in its squared form. So it would look like this. And then you can substitute in your value for cos theta. So they told us in the question that cos theta is 3/5. And so we're going to write 3/5 for cos theta. That squared plus sine theta all squared is equal to 1. And so we're asked to find sine theta, so let's get sine theta by itself. So sine theta squared is equal to 1 minus 3 over 5 squared, which is 1 minus 9 over 25. 25 over 25 minus 9 over 25 gives us 16 over 25. And that was sine of theta squared was equal to 16 on 25. So we're going to square root both sides. And when we square root sine theta squared, we're going to get the principal root, which is just sine theta. But on the other side, when we square root those numbers, we're going to get plus or minus the square root of 16 over 25, which is plus or minus 4 over 5. The square root of 16 is 4 and the square root of 25 is 5. So we've got that sine of theta is actually equal to 2 possible values. But we need to be careful here because we need to go back to our original question and look at the information that we're given. So if we go back up to the top, up here you'll notice that we were told that the angle was in the fourth quadrant. And if we think about which trig ratios are positive in the fourth quadrant, A, S, T, C, cos is the only one that's positive in the fourth quadrant. And so if we're working with an angle that's in the fourth quadrant, then our sine value must be the negative one. So because we've got a restriction on our angle and our angle's in the fourth quadrant, that means sine of theta is minus 4 on 5. So now that we have a sine value and a cos value, we can work out our tan value. Using our formula, that tan of theta is equal to sine of theta divided by cos of theta. So sine we just worked out to be 4/5, cos is 3/5, and our sine value is negative. So we've got negative 4/5 divided by 3/5. So I'm going to invert the fraction, change it to a times, invert the fraction, and we get tan is minus 4 on 3, which you might balk at, but remember tan values can be bigger than 1. So finally, one of the other things that you can do with the Pythagorean identity is you can rearrange it and you can get two seemingly new equations. But what this allows you to do is to replace cos squared theta in an equation with 1 minus sine squared theta and sine squared theta with 1 minus cos squared theta. And we're going to use one of these equations in the example that I have here. Given that tan of theta is equal to 4 and theta is between pi and 3 pi and 2, find the value of sine theta. So we're given tan theta, we're asked to find sine theta, so we better use an equation that relates tan theta and sine theta. And here's that equation. So we're told that tan theta is equal to pi on 4, so we can replace tan theta with sine theta divided by cos theta. So to solve for sine theta, we need to get sine theta by itself. So we're going to multiply both sides by cos theta, and that will give us sine theta equals 4 cos theta. So that's not much help. So what we need to do is to replace the cos theta somehow with sine theta. And we have another equation that relates sine theta and cos theta together. And that's our Pythagorean identity. And I'm going to use the Pythagorean identity and I'm going to solve that for cos of theta. So subtract sine squared theta from both sides and I get my rearranged form. Now remember, cos squared theta is in fact cos theta all squared. And so I can square root both sides of that equation to find cos theta, which gives me plus and minus the square root of the right hand side. And so now I can take this cos value here and replace this cos theta with this, and then tidy up. And now to collect all of my sine thetas together, I'm actually going to square both sides. And so I square the positive and negative 4, which gives me 16, and I square the square root, which gets rid of the square root but leaves me with 16 multiplied by 1 minus sine theta all squared. Now I can expand this out and collect all of my sine thetas, which is what I'm going to do next. So you can see that I've subtracted 16 lots of sine theta all squared from both sides to give me 17 lots on this side. Now I'm going to get sine theta squared by itself. I'm going to divide both sides by 17 and then I'm going to square root. So dividing both sides by 17 gives us 16 on 17, and when you square root both sides, you get positive and negative the square root of 16 on 17. Now, please don't be tempted to think that this is the answer, because there was some information back up in the question that is very important here. And that's this information right here. So it tells us that we're actually working in this quadrant here. And in the third quadrant, only tan is positive. And that means that for our answer down here, since theta is in between pi and 3 pi on 2, then our answer for sine is in fact the negative. Which, if you like, you can square root the 16 on top to give you negative 4 over the square root of 17. It's not absolutely necessary to do that though.